Hi, I'm Swarupa Sail, course instructor for Fluid Mechanics. In this presentation, we will go through loss of head through pipe and major loss. Liquids flow in a pipe due to pressure or gravity. In case of pressure flow, if a piezometer is connected to the pipe, the rise of liquid is H meter. The pressure P and head H are related by the equation P equal to W into H, where W is rho into G. So, P is equal to rho G H. The unit of pressure is Newton per square meter or 1 Pascal, or even it can be kPa, that is 10 raised to 3 Pascal. In case of liquids, it is called head, that is the rise of liquid in piezometer. When a fluid flows through a pipe, it experiences some resistance due to which some of the energy of fluid is lost. The head loss in fluid flow is classified into two categories, that is major head loss and minor head loss. The major head loss in fluid flow is caused due to friction of the conveying pipeline. That is, the resistance is offered by the material of the pipe to the flow of liquid. The internal surface which comes in contact with the flowing fluid causes friction on the fluid layers. The extent of head loss depends on roughness of the pipeline and flow characteristics of the fluid. This head loss takes place continuously in the entire pipeline and is characterized as major head loss. So, major head loss is mainly due to friction. Minor loss in pipe flow is the head loss or pressure drop due to pipe fittings, walls, entrance and exit of pipe, sudden contraction or expansion, etc. This head loss is small in case of very long pipeline, but it may be high in case of small pipe network which involve many fittings and valves. The major head loss can be estimated by the following method. Major loss is equal to head loss due to friction in each pipe. So, we will derive Darcy-Weisbach equation. Consider uniform pipeline through which water is flowing at uniform rate. Let L be the length of the pipe, D is the diameter of the pipe, V is the velocity of water flowing, F equal to frictional resistance per unit wetted surface per unit velocity, HF equal to loss of head due to friction which is exerted by the material of the pipe onto the liquid. P1 is the pressure at section 1 and P2 is the pressure at section 2. If there is no friction resistance, pressure P1 and P2 will be equal. Consider horizontal forces on water at section 1 and 2. We get P1A equal to P2A plus frictional resistance. Divide this equation by W. So, P1A minus P2A divided by W equal to frictional resistance divided by W. This equation can be rearranged as P1 by W minus P2 by W equal to frictional resistance divided by W into A. So, HF is equal to frictional resistance divided by W into A. HF is P1 by W minus P2 by W. And it has been proved from Froude's experiment that frictional resistance is equal to frictional resistance per unit area per unit velocity into area into V square. So, frictional resistance will be F dash into pi dl into V square, which is equal to F dash into pi dl into V square divided by W into A, because HF is frictional resistance divided by W into A. So, once we rearrange, we get HF equal to 4 into F dash LV square divided by W into D. F dash is equal to F into W divided by 2G. So HF is equal to 4FWLV square divided by 2GWD. So final equation for HF is equal to 4FLV square divided by 2GD. This coefficient is called Darcy's coefficient or frictional coefficient, and F is a function of a Reynolds number, and this value of F can be calculated by knowing the Reynolds number. If Reynolds number is less than 2000 or 2100, it will be equal to 16 divided by RE, and if Reynolds number lies between 4000 to 10 raised to 6, then F equal to 0.0791 divided by RE raised to 1 by 4. Next is Chagy's equation. Chagy's formula is used to calculate head loss for open pipe like canal, which can be a conduit, drain, etc. Consider a long pipe through which water is flowing at a uniform rate. Let L be the length of the pipe, D be the diameter, A be the area of the pipe, P is the perimeter, which is equal to pi into D, V is velocity, F dash is frictional resistance per unit area per unit velocity, P1 is pressure at section 1 and P2 is pressure at section 2. We know that P1A is equal to P2A plus frictional resistance. Divide this equation by W. So P1 into A minus P2 into A divided by W is equal to frictional resistance divided by W. Once we rearrange, we get HF equal to frictional resistance divided by W into A. And from Froude's experiment, we know that frictional resistance is equal to F dash into pi dl into V square, which we already have seen for the previous equation. So HF is equal to F dash into pi dl into V square divided by W into A. We will replace pi into D by perimeter P. So F dash into PL into V square divided by W into A. Hydraulic mean depth M or hydraulic radius is the ratio of area of flow to wetted perimeter. So area of flow is denoted by A and wetted perimeter is P. Wetted perimeter means the length for which the water is in contact with the surface of the material in which it is flowing. HF is equal to F dash LV square divided by W into 1 divided by M. So V square will be equal to HF WM divided by F dash L, which is equal to W divided by F dash into M into HF divided by L. So V will be equal to square root of W divided by F dash into M into HF divided by L. We will substitute two more terms in the above equation, that is square root of W divided by F dash is equal to C, which is called as Chagy's constant, and HF divided by L is I, that is loss of head per unit length. So we get final equation for velocity equal to C into square root of M into I. Flow of fluid through a pipe is resisted by viscous shear stresses within the fluid and the turbulence that occurs along the internal pipe wall, which is dependent on the roughness of the pipe material. This resistance is termed as pipe friction and is usually measured in feet or meter head of fluid, which is why it is also called as the head loss due to pipe friction. These are the references. Thank you.